Hi, Year 10. Hope you're well. Well done to everyone who had a go at the submission question from the end of last lesson. It was a tricky one, wasn't it? And well done to those of you who did significantly better than me, because as those of you who watched the solution video know, I got it wrong first time. Anyway, the solution video is correct. That was version 2. And I think I'll link the solution video in class charts on for this lesson as well, because if you haven't watched it, it was a good question. And I just want to pick up the whole when do you divide by 2 thing, which those of you that struggle with that problem will understand what I mean. So I'd like to have a look at this question here. And so let me give you a second just to have a look at this and see if you can answer this question. And my question for part A is going to be, do I need to divide by 2 or not? Okay, pause and have a go. Okay, so first student, you've got 5 choices. Once you've chosen your first student, you've got 4 choices. But do you divide by 2? Well, if Amy and Beth get chosen, is that the same or different to Beth and Amy getting chosen? Well, it's the same, isn't it? So if we say 20 is our answer, we include Amy and Beth and Amy. So I do need to divide by 2 in this case. So the correct answer to that is 10. The order isn't important. If the order isn't important, then we're going to be dividing. So that was different to the question about podiums from a couple of lessons ago, where I said how many different ways could you get gold, silver, bronze. The order there is important, the gold, silver, bronze, the order is important, so you wouldn't have divided there. Okay, so we've got 10 combinations. What's the probability Amy will represent year 11? Well, Amy is going to be with Beth, or Callum, or Dan, or Ellie. That's 4 possible combinations with Amy. So that was 4 out of 10, which is 2/5. And the same is true with Ellie, 4 out of 10, 2/5. And Callum and Dan, well, that's 1 of the 10, isn't it? That's 1 of the 10. So that's 1 out of 10. So what would the question look like if you didn't have to divide by 2? Well, I sort of come up with an alternative question. Okay, so you've got your 5 students going for school council, but because they're year 11, one of them is going to be the chairperson and one of them is going to be the deputy chairperson. So you choose your chairperson first at random, and then you choose your deputy chairperson. So in that case, you've got 5 choices for your chairperson and 4 choices for the deputy. So that would be 20, because Amy being chairperson and Beth being deputy is different to Beth being chairperson and Amy being deputy. The order does matter in that question. So if the order isn't important, if you're just selecting, then you divide. If the order is important, one word that's often used is arrange, one word that's often used is arrange, then we don't have to divide. One other issue that cropped up in that task I set was the whole idea about when an answer is a number of ways it can happen and when it's a probability. So hopefully you can see you've got 9 possible meal combinations from this, because you've got 3 burgers and 3 drinks. But these 2 questions say what's the probability. So veggie burger and cola is one of the options, but it's, as a probability, it's 1/9. So 1 isn't the correct answer, 1/9 is the correct answer. And cheeseburger and coffee, well, she's got, is it she? Jana? Probably. We've got a strategy for helping us with that one in a moment. So I'm going to come back to that one in a moment once we've looked at something. Okay, so my objective for today, which is the 21st, it's a nice satisfying date, isn't it? 21st, the first 21st. Just remembered it's my sister's birthday on the 24th, so I better sort that out. Sample space diagrams. And I'm sort of hoping that rings a bell, probably from year 9, definitely from year 7 or 8. Year 8 actually is when we do it. sample space, the sample space of any situation with probability is the list of all the possible outcomes. So with a dice, the sample space is 1, 2, 3, 4, 5, 6, because that's the things that can happen with a normal dice. And with this question we've just done, the sample space would be a list of all the 10 possible combinations. Amy Beth, Amy Callum, Amy Dan, etc., etc., etc. And as we found in last lesson, we often use multiplication, the product, to work out how many outcomes, and that allows us therefore to define the sample space. There are some techniques that we can use, and the sample space diagram is one such technique. So this question here is very much like the ones we were doing last lesson, and the one I've just done as a starter. We've got Jade, Kyle, Laura, Max and Nicole, and I'm assuming that that's female, male, female, male, female, and they play a chess tournament. And in the player, every player of the tournament plays every other player, and it tells us there are 10 matches. So it's giving us that nudge that this is a divide by 2 situation, because you've got 5 players for the first competitor and then 4 for the second. 5 times 4 is 20. But of course, if Jade has played Kyle, then Kyle doesn't need to play Jade. But in terms of listing out all the possible combinations, we know there are 10 matches. We could do it manually. We could just write Jade, Kyle, Jade, Laura, Jade, Max, Jade, Nicole. But a diagram makes it a whole lot easier, and hopefully you'll remember what I mean as soon as I draw these axes. So we've got, for the first player, we've got Jade, Kyle, Laura, Max and Nicole, and then Jade, Kyle, Laura, Max and Nicole. And we can use the diagram to help us list the sample space, and in particular to answer questions like the ones we've got here. Now the first thing I'm going to do is I say, right, okay, obviously Jade isn't going to play Jade, and Kyle isn't going to play Kyle, and Laura isn't going to play Laura, and Max isn't going to play Max, and Nicole isn't going to play Nicole. So I'm going to start with Jade. Jade's going to play Kyle and Laura and Max and Nicole. Kyle has already played Jade here, so Kyle just needs to then play Laura, Max and Nicole. Laura has already played Jade, and Laura has already played Kyle, so she just needs to play Max and Nicole. By this time, Max has played Jade, Kyle, Laura and Nicole. They're there, so he just needs to play Nicole. And that means Nicole has played everyone. She's played Jade, she's played Kyle, she's played Laura, Nicole, so we've got no extra matches. So the sample space diagram allows us to visualise all those possibilities, and it perhaps helps in those situations where we're not clear whether we should be dividing or not. 2 players are picked at random to play the first game. So we've got 10 games. What they're basically saying is one of those 10 games is going to be our first game, and they're going to pick any one of them at random. What's the probability that it involves a male and female player? Okay, so I'm assuming that the gender here is clear. That's okay. So which of these games, of these 10 games, which of them involves a male and a female? Well, Jade playing Kyle, I'm assuming that's male, female. Jade, Laura, no. Jade, Max, yes. Jade, Nicole, no. Kyle and Laura, that's male, female. And Kyle and Nicole. Laura, Max, and Max, Nicole. So those games I've circled are the ones that involve male and female. So there's 6 of them. So the probability that the first game will be played by a male and female player, it's 6 out of a possible 10. So that's 3/5. So the sample space diagram gives us a way of visualising all the possible outcomes. Now you notice I didn't bother filling it in with JK, JL, JM, JN. Sometimes you're asked to do that, but that's just a waste of time, isn't it? I just used ticks and dashes to show where games were and where they weren't. Here's a slightly different question, but a sample space diagram can help us with this one as well. So we've got 2 bags of sweets. We've got bag A, which I'll put up here, and I've got bag B, which I'll put here. And bag A has got strawberry, orange, lime and blackcurrant. Strawberry, orange, lime and blackcurrant. Bag B has got strawberry, blackcurrant and lime, just 3 in it. So I'll just check. I've got 1, 2, 3, 4 in that, and 1, 2, 3 in that one. Right. Draw a sample space diagram, show all the possible outcomes. Please, when you do this for me in a minute, don't fill it all in. I'm just hoping we can visualise it. And then just see if you can use your diagram to help you answer that question. Okay, so I've started you off with this one. Finish it off and then see if you can answer the question. Okay, because I'm taking a sweet from one bag and then a sweet from a different bag, then I've got no problems with some not happening. So I've definitely got 12 outcomes here. So I know my answers to these 3 questions are going to be probabilities out of 12. Okay, so both strawberry flavour, that's that one there, isn't it? So that's one of the 12. The same flavour, well, I've got strawberry, strawberry, blackcurrant, and lime, lime. I can't have orange and orange because there isn't an orange sweet in the second bag. So that's 3 out of 12, which is 1/4. And then the different flavours one, well, I've identified the 3 that were the same flavour. So different flavours must be all the others, mustn't they? So 3 of the 12 were the same flavour. So 9 out of 12, or 3/4, is the probability you get different flavours. Of course, sometimes you do get a sample space diagram where you're expected to actually fill it in, and I'm sure you've done questions like this before. So we'll just do one very quickly. We've got a dice, 1 to 6. We've got a spinner, 1 to 4. We roll both and we add the scores together. So we are asked just to fill in this and work out those probabilities. So fill it in and have a go at that for me. Okay, so hopefully you filled it in. I always like these because they're sort of, you get the stripy patterns. So the probability of getting a 4, you've got 1, 2, 3 ways that can happen. 3 out of 24 total ways. 6 by 4, 24 total ways. No need to divide by 2 because it's different dice and spinner. Total is a square number, so that's the 4s are square numbers. 1 is a square number, but you can't get a 1. And 9 is the next square number, 3 times 3, so 5 ways out of 24. And you can't get a total of 12, so that's impossible. So let's come back to this question I talked about earlier and use the sample space diagram to help us. So I've got hamburger, cheeseburger, veggie burger for my burger, and for my drinks I've got cola, lemonade and coffee. So we know we've got our 9 possible meal combinations. Probability she chooses at least one of cheeseburger or coffee. So there's 3 cheeseburger combinations and there's 3 coffee combinations, but of course we've already counted 1 with the cheeseburger. So what we've got there is 5/9 is the answer to that question. And again, it's a probability question, so the answer isn't 5, it's 5 out of 9, 5/9. Okay, so the second objective for today is just a quick recap of this idea that when you have a number of outcomes, a sample space, their probabilities will always add to 1. So just 4 quick fire questions to illustrate that. So on a 6-sided dice, probably getting a 1 is 1/6. Probably getting not 1, well, that's all the other outcomes added together. It must be 5/6 because together those add up to 1. In a pack of cards, hearts are one of 4 types. They're called suits. So 1/4 of the cards are hearts. So the rest are not hearts. So the probability of getting a card that is not a heart is 3/4. Weather comes in all shapes and sizes, but it is definitely either raining or not raining at any one time. So the probability it rains is 0.88, and the probability that it isn't raining is 0.12. So here's a slightly more involved question. We've got here a dodgy dice. So the probabilities aren't 1/6 of each number. For some reason, they are all different. So pause and tell me what the probability of getting a 6 on this dice is. If I add up all these probabilities, they come to 0.85. So this one has to be 0.15 because when you list all the possible outcomes, their probabilities will always add to 1. Now, I'm almost embarrassed to start doing that. I did say we would fly through this, but let me just try and make it a little bit trickier for you. So this question here, we are told that you've got a spinner with 4 numbers, 1, 2, 3, 4. They're not equally likely. The probability of getting a 1 is 4x, 2 is 3x, 3 is 2x, and 4 is x. So your first question is working out what x is. And once you know what x is, you can work out each of those probabilities, and then you can answer those questions. So can you think about how you can work out x? Go on, pause, have a go. If I add these together, I get 10x, 4x plus 3x plus 2x plus 1x, and I know the probabilities in any situation always add up to 1. So x must be 0.1, or 1/10. So that means that's 0.4, that's 0.3, that's 0.2, and that's 0.1. Okay, having worked that out, the probability of getting a 2 or a 4, so that's 0.3 added to 0.1. And the probability of getting a 1, 2 or 3, so that's 0.4 or 0.2, sorry, 0.3 or 0.2. It's everything apart from the 4, so that's 0.9. Well done if you got that. Okay, here's a slightly more involved question. So start off by working out your missing probability. But then see if you can answer B and C as well. Pause and have a go. Okay, do you get the missing value 0.3? Not male vocal, so not that is going to be all the others added together, 0.85. Now, she's randomly picking a CD from her collection, and the chance of getting a female vocal CD is 0.1. That's a tenth. So that means 1/10 of her CDs must be female vocal ones. 1/10 of 80 is 8. Well done if you got that. So here's just a quick question for you to submit on Onenote. I've added it to a fresh page in your homework folder, and some of you are using email because Onenote's misbehaving. That's fine. It won't take you long at all, but you've just got 2 gaps to fill in, and you have to read the question carefully to work out how you're going to fill in those gaps. This is nowhere near as tricky as the last one I asked you to submit, but worth doing all the same. Okay, I will see you again tomorrow.